Hi, my name is Adrian, and over the summer I worked in Dr. Leroy's laboratory working with nanomaterials to specifically make devices. So currently, there's a societal push towards nanotechnology, or more specifically with nanoscale devices at its forefront, which simply put is stacks of atomically thin materials. One of the biggest problems with research in this field is the lack of a replicable and reliable method for the fabrication of these devices, which is where my research came into play, where my team and I fabricated a device using a replicated 4-step method. The device we created was a repeating structure, as shown on the left, of atomically thin graphene, which is hexagonal structure of carbon atoms, and bulk hexagonal boron nitride, which is the same structure, but it uses boron nitrogen instead of carbon. Throughout this entire process, we made sure to ensure quality through 3 main factors: that being a consistent uniformity across the piece, a maximized size of the piece or contact area, and then a minimized residue around the piece or defects. But how do we actually fabricate the device? In the first step of the 4-step process, separation, we removed an atomically thin layer from a bulk material using the Scotch tape method, and then we placed it on a silicon wafer. And the next step, the searching step, we looked under an optical microscope where the color of the piece would give insights into thickness. Then in the second to final step, we made sure to use an atomic force microscope. We're able to measure nanoscale variations in height across the piece in order to confirm its thickness and also its uniformity. Finally, we actually created the device in the end using the dry transfer technique, where we use a viscoelastic stamp and heated it up or cooled it down to make sure we were laying the pieces on each other as precisely and slowly as possible. In the end, we successfully fabricated a device as shown in the bottom of the slide. But why is this important? It's important because it provides a foundation for scalable and reliable device fabrication in the future, which is an essential step in next generation electronics, such as those in our cell phones in our pockets, as well as quantum measurements in the lab. Future research can work towards automating this process, making it faster, as well as work with more sensible materials like transition metal dichalcogenides. Thank you.